Good morning, students. The next topic we are going to see is about wattless current. So, consider an AC circuit in which there are phase angle phi between VRMS and IRMS. So, we are considering the two things, which is VRMS and IRMS. So, between that two, let us consider that angle to be phi, and the voltage is assumed to be leading the current by the angle phi. So voltage வந்து இதில் lead ஆகும் அப்படின்றத நம்ம consider பண்ணிக்கிறோம். Okay, so considering with this, and when you see the current here, so this is VRMS, this is IRMS, this is angle of phi. Now in this the current is being going to be resolved into two components. So in the current என்ன பண்றாங்க, ரெண்டு காம்பனண்டா பிரிக்க போறாங்க. Okay, so this is the value of current, and that current, if you are splitting, that is split into two components here. So one value is what, IRMS into cos phi. Okay, so here we have IRMS into cos phi, and how that IRMS into cos phi is, that is along the direction of VRMS. So VRMS in the direction la irukko adhe direction la IRMS cos phi irukku. Okay, so next is what, IRMS into sin phi. Okay, so here we are having the value IRMS into sin phi. So how that value is, that is perpendicular to this VRMS. Okay, so it will be in this direction, so it is perpendicular to the VRMS. Okay, so these are the two components in which IRMS is split. So IRMS is split into two components, IRMS cos phi and IRMS of sin phi. Clear? So one value is along VRMS and the other value is perpendicular. Clear with this? So this is how the diagram is. So this is IRMS. இதில் இந்த சைடு வந்து cos phiயும் இந்த சைடில் வந்து sin phiயும் வந்து. So the component of current where we are seeing is IRMS cos phi, that is in phase with the voltage. அதுக்கு பேர் என்ன சொல்றாங்கன்னா active component சொல்றாங்க. Why it is in phase? Because it is along the same direction ன்றதுனால. And so the current is given by VRMS IRMS into cos phi, that is called as a wattful current. Okay, so that is a power which is flowing, so that is called as a wattful current. Next other component இருக்கு இல்லையா, that is what, IRMS into sin phi. அதில் angle எப்படி இருக்கு, நம்மளுக்கு pi by 2 இருக்கு. இதில் active component, இது என்னன்னா reactive component. அப்போ power என்ன இருக்கு, இதில் 0, இதில் power இருக்கு நம்மளுக்கு, இதில் power 0. so power வந்து இல்லை அப்படின்றதுனால அதுக்கு பேர் தான் என்ன சொல்றாங்கன்னா wattless current. Clear? So IRMS cos phi எப்படி இருக்கு, along the direction இருக்கு, அதனால அது active component, அதுக்கு power இருக்கு, அதனால wattful. Next இது வந்து it is in the perpendicular direction அப்படின்றதுனால reactive component இருக்கு, power வந்து 0, so that is called as a wattless current. Clear? So this is the definition of wattless current. So next we have power factor. So power factor is defined in the following ways. We have various formulas for power factor. They are, first, power factor is equal to cos phi. That is also equal to the cosine of the angle of lead or lag. So இதை தான் நம்ம என்ன எழுதிருக்கோம்னா இப்படி எழுதிருக்கோம். So cos ன்றது என்னது cosine, phi ன்றது என்னது angle. Angle of என்ன இருக்கலாம், lead இருக்கலாம் இல்லாட்டி lag இருக்கலாம். Okay. Next formula is power, which is equal to R divided by Z. R ன்றது என்னதுன்னா resistance, Z ன்றது என்னதுன்னா impedance. Okay, so power factor is equal to resistance divided by impedance. Okay, so next formula is power factor is equal to VI cos phi divided by VI, where VI is said to be the true power divided by apparent power. Okay, so these are the three formulas for power factor. First formula is power factor is equal to cos phi. Next is power factor is equal to resistance by impedance. Then true power by apparent power. Clear? First, we have few examples for power factor. Power factor வந்து cos வந்து 0 இருந்துச்சுன்னா அப்போ equal to என்ன ஆயிடும், 1 ஆயிடும், because cos 0 is equal to 1. For pure resistive circuit, இது வந்து resistive circuit தான், ஏன்னா angle phi between the voltage and the current is 0. Since the angle is 0ன்றதுனால இது வந்து resistive circuit அப்படின்னு சொல்லியிருக்காங்க. Okay, then next is we have the power factor is equal to cos pi by 2. Cos pi by 2 என்னது 0. இது எதுக்கு, inductive and capacitive circuit க்கு, because only for inductive and capacitive circuit the phi is equal to pi by 2. Next, the power factor lies between 0 and 1. So இதுக்கு முன்னாடி கண்டிஷன்ல என்ன பார்த்தோம், 0, இதுல 1. So அதனால என்ன சொல்றோம், 0 and 1 குள்ள தான் இந்த வேல்யூ இருக்கும் அப்படின்றது சொல்லியிருக்கோம். Clear? Okay. Next is advantages and disadvantages of AC over DC. So the first point is the advantages. The generation of AC is cheaper than DC. Okay, so AC is comparatively cheaper when you compare with the DC. Then Next is when the AC is applied at higher voltage, the transmission losses are small compared to the DC. So high voltage நம்ம வந்து AC power வந்து transmit பண்ணோம் அப்படின்னா it transmits with a less losses. Okay, losses வந்து கம்மியா இருக்கும் அப்படின்னு சொல்றாங்க. Then next third point is AC can easily convert it into DC with the help of rectifiers. So AC use பண்ணோம் அப்படின்னா we can convert into DC. AC is what? Alternating current. Okay, so this alternating current, it can be converted into a direct current easily with the help of what? Rectifiers. Okay, then what are the disadvantages is alternating voltages cannot be used for certain applications. Certain applications க்கு நம்ம alternating voltage use பண்ண முடியாது, like charging of batteries, electroplating, electric transduction. So இந்த மாதிரி ப்ராசஸ்க்குலாம் என்ன பண்ண முடியாது, AC யூஸ் பண்ண முடியாது. We can use only DC, direct current. Okay, and at high voltages it is more dangerous to work with AC than DC. Okay, so DC is not dangerous at all, but AC is more dangerous. Okay, when you work at a high voltages. Okay, so these are the advantages and disadvantages. First, what are the advantages is the first point, it is less cost. That is, it is cheaper. Then it can be transmitted without any loss. Then it can be easily converted to DC. These are the advantages. Disadvantages are it cannot be used for certain applications and it is more dangerous to work with AC than DC. Clear? Thank you.